Welcome back to Archean. This is a coding video on how to compute the direction from one beacon to another. And what we have set up here is we have a beacon on an arm that's connected to a pivot, and we have another beacon in the center point. So the stationary beacon is exactly over the pivot, so they're lined up. Now imagine this square is a graph, and up and down is y, and left and right is x. So given that, if you know the x and a y, and you do a quick internet search how to convert xy to degrees, you'll find a hit, and that hit explains what this code does. Now you may notice that, wait a minute, you're getting z, you're not getting y. Well, this is a three-dimensional game, and in it the y is actually up and down, x is left and right, and z is forward. So we remap z effectively to y when we do the calculations. Now if you wonder why the pivot has stopped, that's because I had to freeze that video frame because my dialogue exceeded the length of the video. So we're just going to freeze the video for now so I can talk about the coding. All right, so it's pretty straightforward. I have a toggle switch, and a toggle switch on line 26 is used to set the pivot with a given velocity. We want to go clockwise, so that velocity is a negative value. And I've already set the pivot to be, I unchecked the servo mode. So that means it's in velocity mode. And that should be straightforward. If you turned on, it's using -01. If it's turned off, it's 0 to stop it. Computing the pivot direction, well, we query the angle. And because the pivot numbers go counterclockwise, we 1 minus the value, so we want to go clockwise, multiply by 360, and boom, we have the degrees. That's pretty simple and straightforward. In line 32 and 33, we grab the x and z coordinates. Now we're grabbing this from the beacon that's in the center, and the xy represents the moving beacon. I previously have set the moving beacon to be transmitting, and the stationary one is receiving. I don't actually show that in this video, but that should be straightforward. So we grab the x and z, and as I said before, because this is a three-dimensional game, in this case x is left and right, and z is forward and back. If the z is negative, it's ahead of you, it's behind you, it's positive. So the magic is in line 36. As I said, I just looked this up, and instead of using y, I use z. So that's really the only change. Now, and as you see, it spins around and matches. So I set this up to go around just to verify that the location of the moving beacon and the computed angle between is correct. And it does spin around, as you saw, went through a complete cycle, and I do match. Now while moving, it's within 1/10 of a degree. If I stop the rotation by using the switch, then they lock in, and they're both the same number, to 1/10 of a degree accuracy. That's more than enough precision in my case. And then in line 38 and 39 and 40, I just rendered a display. And I'll put the link to the where I found this information at in the description, so if you want to look it up yourself. But effectively, I just took the answer and stuck it in the code in line 36 and double checked it and verified it. All right, that's all for this video. Until next time, see ya.